Have you ever noticed that a modern factory can have hundreds of machines running together perfectly? Conveyors move products, motors start and stop automatically, robots assemble components with incredible precision, and operators sitting in a control room can monitor everything on a computer screen. But here's the interesting question. How do all these devices communicate with each other? How does a PLC know when a sensor detects an object? How does a VFD know when to change motor speed? How does SCADA know what's happening on the production floor? And here's something even more surprising. A single communication cable can replace hundreds of wires inside a factory. Sounds amazing, right? By the end of this video, you'll understand exactly how PLC communicates with other devices and why communication is the backbone of industrial automation. Let's begin. Imagine it's 2 o'clock in the morning. A bottling plant is running at full production. Thousands of bottles are moving on conveyors. Everything is working perfectly. Suddenly, one conveyor stops. Within milliseconds, a sensor detects the problem. The sensor sends information to the PLC. The PLC analyzes the situation. It sends commands to stop upstream machines. An alarm appears on the HMI. A warning is sent to the SCADA system. The operator immediately sees the fault. All of this happens before anyone physically reaches the machine. How is that possible? The answer is communication. In industrial automation, communication means exchanging information between devices. Think about your smartphone. When you send a WhatsApp message, your friend receives information. Communication in a factory works in a very similar way. The PLC acts like the brain of the system. It receives information, processes information, and sends information to other devices. Now let's see who talks to the PLC. The first device is a sensor. Sensors are the eyes and ears of the PLC. They collect information from the real world. For example, a proximity sensor can detect whether an object is present. A temperature sensor can measure heat. A pressure sensor can monitor pressure inside a pipeline. Whenever these sensors detect something, they send information to the PLC. The PLC then decides what action should be taken. Let's take a simple example. Imagine a water tank. A level sensor detects that the water level has dropped below a minimum value. The sensor sends this information to the PLC. The PLC processes the signal. Then it sends a command to start a water pump. The pump fills the tank. Once the tank becomes full, the sensor informs the PLC again. The PLC then stops the pump. This entire process happens automatically. No human intervention is required. Now let's talk about HMIs. HMI stands for Human Machine Interface. You can think of an HMI as the communication bridge between humans and machines. The PLC and HMI continuously exchange information. The PLC sends machine status, temperatures, alarms, and production data to the HMI. The HMI displays this information to the operator. At the same time, operators can send commands back to the PLC using the HMI. For example, they can press start, stop, reset alarms, or change machine settings. This two-way communication makes operation easy and efficient. Next comes the VFD, variable frequency drive. The PLC and VFD communicate continuously. Suppose a conveyor motor needs to run at different speeds. The PLC sends speed commands to the VFD. The VFD adjusts the motor speed accordingly. At the same time, the VFD sends feedback information back to the PLC, such as motor speed, current, voltage, and fault status. This allows the PLC to monitor and control the motor intelligently. Now let's talk about one of the most important concepts in industrial communication: communication protocols. Think of protocols as languages. Imagine you speak Hindi and your friend speaks only Japanese. Communication becomes difficult. Similarly, industrial devices must speak the same language to understand each other. These languages are called communication protocols. Some popular protocols include Modbus, Profinet, Ethernet/IP, Profibus, DeviceNet, and many others. Each protocol defines how information is sent and received between devices. Without a common protocol, communication cannot happen. Now here's where things become really interesting. Years ago, factories used huge numbers of wires. Every signal required separate wiring. Large control panels became crowded and expensive. Today, communication networks have changed everything. Instead of hundreds of wires, a single network cable can carry thousands of data points. Just like the internet connects millions of computers, industrial networks connect PLCs, HMIs, VFDs, robots, and SCADA systems. This reduces wiring, reduces installation cost, improves troubleshooting, and increases flexibility. Now let's follow the complete journey of data. A sensor detects information. The information reaches the PLC. The PLC processes the logic. The PLC sends commands to output devices. The devices perform actions. Production information is sent to SCADA. Operators monitor everything in real time. This cycle repeats continuously, thousands of times every second. This is called the PLC scan cycle, and it is the heartbeat of industrial automation. Now look around any modern industry. Automobile manufacturing plants, food processing factories, pharmaceutical industries, power plants, oil and gas facilities. Everywhere you will find PLCs communicating with multiple devices. Without communication, machines cannot coordinate. Without communication, automation cannot exist. And this is why communication is one of the most important skills for electrical and automation engineers. Whether you want to become a PLC programmer, automation engineer, maintenance engineer, SCADA developer, or control system specialist, understanding communication is absolutely essential. So remember this simple formula: sensors collect information, PLC processes information, output devices perform actions, and communication makes the entire process possible. Today you've learned how PLC communicates with sensors, HMIs, VFDs, SCADA systems, and other industrial devices. In the next video, we'll actually configure communication between a PLC and an HMI step by step and see real industrial examples. If you found this video useful, like the video, subscribe to the channel, and comment PLC Master below. Thank you for watching. I'll see you in the next video.